Welcome to proChem Academy, and this will be the second lecture of this chapter Aromatic Hydrocarbon from the class 11, and here we will discuss about the classification of more compounds. Those are aromatic and their names, and the difference between aromatic, anti-aromatic and non-aromatic compound. Have you seen the previous lecture? So if you want to see, please see the YouTube lecture. So here we will discuss about more aromatic compound. Like suppose benzene with COCH3 group. This compound is called acetophenol. In the previous lecture, I have given so many examples of the aromatic compounds. Now I am starting from this compound. This compound is very good compound, and we will see during the periodic of reaction, periodic of acylation, one of the best example of aromatic compound reaction. We will see the preparation of this compound there. So this is called acetophenol. Now if benzene is with a alkyl group like CH2CH3, this compound will be called as ethyl, because this CH2CH3 group is ethyl group with benzene. Okay, so ethyl benzene. Now we can give more naming of the compounds. Like suppose for that we have to learn some tricks about these aromatic compounds. That this benzene compound have 6 positions, 1, 2, 3, 4, 5, 6, and all these positions have a particular name. Suppose if I mark like this 1, 2, 3, 4, 5, 6, then the positions which are neighbor to each other, they are called ortho to each other. Or we can say ortho positions, neighbor to each other. Suppose these 1, 2 are ortho to each other, 2, 3 ortho to each other, 3, 4 also ortho, and 4, 5 and 6, 1 again they are ortho to each other. Now understood? So the groups which are neighbor to each other, they are called ortho to each other, and they said as a ortho positions. Okay. Now if suppose 1 and 3, the positions which are 1 carbon gap, it means 1 and 3 they are meta to each other. We can say meta to each other, it means these are meta positions. We can say again 3, 4, 5, 1, 5 also meta positions. Okay. Now again the positions which are completely anti to each other, means opposite to each other, they said as para to each other, and it means para positions. So 1, 4 positions are para positions. Again we can say 5, 2 positions and para positions because it is opposite, and here 3, 6 positions are opposite to each other, para position. So these are para to each other. 1, 4 para position. Now we can give the name of the compound of this aromatic compound in such a way so that when a particular group is already present in an aromatic compound, now by reacting with some reagent, other groups are substituted in that aromatic compound, then we can give the name of the compound. Okay, because these aromatic compounds like benzene, most of the aromatic compounds are benzene and benzenoid compounds. So these benzenoid compounds will participate in substitution reaction, and more groups may be substituted in a benzene ring, not only one. Suppose if OH group is already present in the benzene ring, then this OH group will decide where the upcoming group will substitute. If another group comes in this position, then it is decided by this OH only. Now we can give the name of this compound. Okay. Now how to give the name of this compound? when benzene with OH, we say phenol. Now phenol is the base, and in its neighbor position, CH3 group is there. It means this CH3 group is ortho to this OH, because this position will be ortho position. This position will be ortho to this OH. Ortho position. Because it is neighbor to OH. Okay. So this, if CH3 group is there, then we can say that it is ortho CH3 and ortho OH. Okay. Then again, if bromine is substituted in the ortho position, this is ortho position, then you can give the name. How will we give the name? This is ortho position and here bromine is substituted, so we say ortho bromo phenol, because phenol is the base. So this name can be given like this also, that we say ortho means O, then one hyphen, then bromo, then after phenol. Ortho bromo phenol. Now this compound also we can give name, that this will be para position because it is completely opposite to OH. This one is said as para bromo phenol. Okay, ortho bromo phenol, para bromo phenol. Then again we can say, suppose CH group is there already here in the same string, and CH group, one OH group is there at the ortho position of this benzene ring with CHO. So this CHO is the basic name. With benzene with CHO we say benzaldehyde, and in ortho position OH group is there, so we'll say that it is orthohydroxy benzaldehyde. We'll say orthohydroxy benzaldehyde. Okay, so for this, to understand the naming, I have told you this one, but later on we will discuss briefly about this, why this bromine is coming in para position, why this bromine is coming in ortho position. Later we will discuss. So here we will discuss about the naming only. This compound is orthohydroxy benzaldehyde because ortho position is substituted by OH group, and we have a common name of this compound also, that is salicylic. This compound is salicylic. So we write some of the name of the compounds. Okay, salicylic. CHO with OH. COOH with OH. It is salicylic acid because acid group is there. Okay. Salicylic acid. It is also called orthohydroxy benzoic acid because when COOH group will be there, that is benzoic acid. So it is orthohydroxy benzoic acid. Clear? Now, if NO2 is there in the benzene ring, we say it is nitrobenzene. Nitrobenzene. If SO3H group is there, we say benzene sulfonic acid. We have to read all the names, as much we can memorize, we have to read. So this video will be continued with the previous video where I have given some of the naming. Okay, so this will be benzene sulfonic acid, benzene with SO3H. Now again, if already one nitro group is there in the benzene ring and another nitro group is placed here, so we know already that this is the meta position because these group are placed with one carbon gap. So this is meta position. So now two nitro group is there. When only one nitro group will be there in the benzene ring, we say nitrobenzene. But here two nitro groups, so it will be dinitro. Okay, and at what position? At is meta position. So we say meta dinitro benzene. Meta dinitro benzene. Now same, if two OH group are ortho to each other, it has a common name. It is called catechol. Okay, I'm just going to discuss about some of the compounds to you. Actually, you have to read out, because when we will see the name reaction, these compounds may come as a product. So you have to know the name. This is catechol. Now, if two OH group are at the meta position of each other, they can present. It is a particular compound, and we say it is a resorcinol. It is called resorcinol. Okay, when two OH groups are meta to each other. Now again, if two OH groups are para to each other, we say benzoquinol. This compound is said as benzoquinol, or we can say hydroquinone. Okay, this compound can be named as hydroquinone also. Okay, so these are the naming of some more compounds may be there. So we'll discuss later on. We will get some halic acid, we will get anthranilic acid, we will get. Okay, so those compounds we'll discuss later. Now we'll discuss about the aromaticity, anti-aromaticity, and non-aromaticity. Now, one famous scientist called Huckel, he said that Huckel, Huckel, he said that the compounds which will be aromatic, they have a particular nature, and those compounds will be exceptionally stable if they follow these rules. The compounds which will be aromatic, they should have 4n plus 2 number of pi electrons. They should have 4n plus 2 number of pi electrons, where n is 0, 1, 2 or 3 etc. The compounds which will be aromatic, they should have 4n plus 2 number of pi electrons, and also they should have a planar cyclic structure where electrons can be delocalized. Okay, they should have a planar and cyclic structure with, and number 3 we can say delocalization of pi electrons. So those compounds can be said as aromatic. Maybe benzenoid or non-benzenoid, also they can be aromatic. So these are the rules of aromaticity. 4n plus 2 number of pi electrons will be there, planar and cyclic structure, and delocalization. Suppose I am giving one example with benzene. This is benzene. Now you see how many pi electrons are there. And if it is an aromatic compound, then it will satisfy these rules. These 3 rules it should satisfy. Now benzene has how many pi electrons? These 3 pi bonds are there. It means 6 pi electrons are there. Now benzene has 6 pi electrons. Now these 6 pi electrons will be satisfied by this 4n plus 2 rule. Suppose I am 4n plus 2 I am taking, and after placing 0, 1, 2 or 3 anything, if I can get this 6 pi, then we will say that this is satisfied. Actually, if I put 1 instead of this n, then we get 6 pi. So this rule is satisfied. This rule is satisfied. Okay. So it is aromatic we can say, but other 2 rules we have to follow. Number 2, it is planar or not, we have to see. This one is cyclic, we can easily say this one is cyclic, but it is planar or not. To get a planarity, the carbons which are there in the benzene ring, it should have sp2 hybridization. What hybridization? sp2. Now if I draw this structure like this carbon has one hydrogen, we know. And how to calculate the hybridization? The carbon, center carbon should have at least 3 sigma bonds surrounding it, so that it will be a sp2 hybridized. Like this carbon having 1 sigma bond, so it is sigma, it is also sigma, and this is also sigma. And this pi electron will not be considered because pi bonds will not participate in the calculation of hybridization. So how many sigma bonds are there? 3. So 3 sigma means sp2. So when a compound having a carbon and is sp2 hybridized, it is planar in nature. So this compound, this benzene is planar, and we say cyclic also. Now the third rule we have to see, it is delocalized or not. This benzene, already in the first video I have told you, in the previous video, that this pi electron can be delocalized. This pi electron can shift towards the neighbor to turn. It can shift it. So when they are shifting, it can form this kind of position. So delocalization is possible. Resonance delocalized. So this benzene is aromatic compound. What do we say? Benzene is aromatic compound. Now, all the benzenoid compounds, what I have drawn here previously, all are aromatic compounds. Okay? So, we will take one example next day. Some questions we will take, and we will see those compounds are aromatic or not aromatic. Okay? Now, same word we have like aromatic, that is anti-aromatic. Now, the compounds which will be anti-aromatic, they will not have 4n plus 2 number of pi electron. They will have 4n number of pi electron, and others structure will be same, like they should have resonance and they should have a planar and cyclic geometry. Okay, suppose, so I am telling about anti-aromatic compound. The first rule is that they should satisfy this rule. They should have 4n plus 4n number of pi electron. Okay, only 4n pi electron, where n is 0, 1, 2, 3, etc. They should have planar and cyclic geometry. Structure is there, and there should be resonance, stabilization or delocalization, you can say. If these 3 rules are satisfied, then the compound will be anti-aromatic. Okay. Suppose this compound, cyclopropyl cation, or this one. This is cyclotetradiene. And here how many pi bonds are there? 2 pi bonds means 4 electrons. Here 2 and here 2. Now 4 electrons means 4n rule will be followed, because if you put 1 instead of this n, you will get 4 pi electrons. Okay, so it is anti-aromatic rule is followed, number 1. Now this compound is cyclic and planar because this every carbon, each carbon having sp2 hybridization, sigma, sigma, sigma. So this carbon is sp2 hybridized. So number 2 is followed, that planar and cyclic. And number 3 we have to see that it is resonance, canonical it has or not. It has actually. This pi bond can shift here, so that this pi bond will shift. So we'll get this kind of structure. sorry. So it is anti-aromatic. Okay, it is anti-aromatic. Now another type of is there that if the compound is not cyclic, not planar, and resonance contribution is not there, then though the compound has 4n or 4n plus 2 number of pi electrons, then they should not consider as anti or aromatic. They should be considered as non-aromatic compound. Okay, so the compounds do not have planar geometry or resonance delocalization if they have 4n or 4n plus 2 number of pi electrons, but these two rules are not satisfied, they will say this is non-aromatic compound. Okay, so for non-aromatic compound, maybe 4n plus 2 or 4n pi electron may be there, or do not have planar cyclic structure and do not possess resonance delocalization. Okay, one example let me take. This compound is called cyclooctatetraene. Cyclooctatetraene, and how many pi electrons are there? 2, 4, 6, 8. 8 pi electrons is there. So it may be going by 4n rule, because 4 into 2, it is coming 8 pi electrons. So though it has 8 pi electrons, it is not anti-aromatic, because someone will think that by satisfying number 1 it is anti-aromatic, but it is not. Though the compound is looking like this, it is not actually like this. Due to angle strain, this compound is not stable. This compound is not stable because this angle strain. This compound will flip itself to get this kind of structure. One, two, three, 4, 5, 6, 7, 8. Due to angle strain, all the carbons are sp2 hybridized. We know all the carbons are sp2 hybridized, but sp2 hybridization should maintain one angle, that is 120 degree. But here the angles are not maintained, so they, to get stability, it flips itself to get this kind of structure, and it is not planar. This structure is not planar, and from here we cannot get the resonance delocalization. Okay, resonance is not possible for this compound. Clear? So this cyclooctatetraene is not a aromatic, not an anti-aromatic, it is non-aromatic compound. Okay. So in next video we will take more examples and we will try to discuss the questions answers. So before that, if you like this video, please do like, subscribe and share my channel. Thank you.